just do a quick whistle-stop tour of two schemes I'm involved with, one in a rural area, one in an urban area, and these are the links to the two projects. I work for the Mersey Forest. We've planted 9 million trees since the 90s. 60% of people who live in the Mersey Forest region say that's improved their lives. 1 in 6 properties in the UK are at flood risk. Places like Warrington are some of the highest flood risk in the UK. So the challenge has been to me is to do more with trees to slow the flow of water and hold up water in the landscape. So I have a few engineers and hydrologists come to speak to predominantly architects today. Well, natural flood management is all about designing and building things, as is shown in these photos here. Ultimately, we can't turn back the clock on time and abandon agricultural land and let it turn back to nature, because there's a food agenda and other agendas of a demand for housing. So it's about green infrastructure and designing in attenuation into our landscape. And this is what we've been doing up in St Helens. We've been using the Environment Agency and others, and we've built over 1 kilometre of leaky barrier over about 11 different features to slow the flow of floodwaters upstream. For instance, this is just one leaky barrier in a pond upstream of a series of properties that flood a few hundred metres upstream. And we've put in a soil bund behind this in the next few weeks. And the idea is it just gives a bit more freeboard and a bit more storage to help those properties downstream, which are, in the last event in 2015, flooded internally. So first example is urban fringe or rural natural flood management in an area called St Helens. This is the area in question. So it's Black Brook. Black Brook is at the outlet of that 24 kilometre squared catchment, and it's at the confluence of a series of 3 rapid response catchments, which are very flashy, with that rainfall coming down to run off very quickly. And the red areas there show where those water courses are in pipes, undersized pipes or undersized bridges, which means in a high flow, so yeah, high water level or flow volume, can't actually pass through that system and out, and floods this area. So we've done some hydraulic modelling of that, and these are the depths of water for a 1 in 100 year event. Quite scary, around 2.4 metres of water. What happened in Cumbria had an initial estimated return period of 1 in 800 years, just to put that in modern day context. So those are those properties here. That's what it actually looks like when it goes under. It's happened 3 times since 2000, last event on Boxing Day. So natural flood management is all about what we could do to hold up that water in the landscape. So as part of that, we needed to understand just how much water do we need to hold upstream so it just won't flood Black Brook downstream. And hydraulic models can be used and manipulated to see how much water spills out. So in that 1 in 100 year event, 250,000 cubic meters of water spill out into the floodplain. To give some context to that, that looks like 120 Olympic swimming pools full to crest of water. And by holding that upstream, the river's still flowing, but it gives the pipes, gives the bridges chance to pass that flow through. And so we've been building these leaky barriers upstream, 11 of them as I've described. This is just one of them. It's an engineered log jam. The stream ordinarily flows through here, but in a high flow, the water's forced onto the floodplain and across. And basically, 4 of those features together in one location hold back 2,500 cubic meters of water. So that's about 1 Olympic swimming pool. So there's 119 more Olympic swimming pools to attenuate, or in other words, 400 more of those are required in the catchment, or similar types of attenuation, perhaps by different methods, to take that risk away. But since installation, we discovered some other things about these features. So we set up a series of monitoring points from inflowing to outflowing waters. That's Dam 2, which is in the picture back here, the photograph taken pointing this way. And this is a depth of water for a 1 in 20 year event. And from the inflowing to outflowing waters, phosphate, which is implicit in eutrophication and water quality decline, comes in at about 4 milligrams per litre and goes out at about 0.5 milligrams per litre. So that's a 90% reduction on phosphate. Normal clean salmon rivers, you'd see 1 milligram per litre of phosphate or less, just to put that in context. So it's very dirty, enriched water. Again, nitrate shows reduction too. And we've had a PhD student study that site. They've discovered that by 2035, over those 4 dams, a third will be full of sediments. That sediment held upstream, not at the pinch points like the bridges and the culverts, giving them still more capacity to maintain clear flow through. So we're doing that in St Helens over here, but across the northwest, there is thousands upon thousands of properties at flood risk, indicated by these points here. And there's lots of small catchments upstream which would be suitable for these natural flood management interventions, potentially combined with harder types of engineering measures such as defence walls and flood alleviation schemes. Green Alliance, a bunch of economists, went to look at the Sankey Valley scheme and assessed what the cost for water companies is when they have to remove contaminants conventionally, or when a section of road gets eaten away at by a river, what the cost is. So that's a business as usual approach. They looked at the business as usual approach, and then they looked at the attenuation scheme in St Helens, the Sankey scheme, and said, if we implemented this, how much would it cost? And they compared the two figures, and the NFM's 11.2 million less in a hypothetical example. So there's efficiency savings there to be made, and there's also the capability to introduce the private sector to those sorts of schemes. There's large industrial facilities within the Sankey catchment, including the likes of Pilkington and others who make the flat glass. So we talked briefly there about the rural situation. We're going to switch on to the urban situations. This is what Liverpool roughly looked like prior to urban development. The pool of Liverpool, Fosse Lake, and some tributaries coming down here. This is where Liverpool main centre is now. And Liverpool's gone from that to that. So over 90% of the watercourses are in pipes, undersized pipes, or have disappeared completely. And that means in the present day, when those drainage systems are overwhelmed, that there is a flood risk. So this area of surface water flood risk, which is in the Liverpool 1 district where all the nice shops are, very high value commercial property, concurs with where Fosse Lake used to be. And this is the old estuary of Liverpool and the reclaimed land for the docks, which was part of the industrial growth of that area. But accordingly, it now has created more risk. So as part of the 3.2 million European Union funded Urban Green Up project, we're setting about planting 100 trees through Liverpool. And the aim of that is basically to take out these overland flow pathways to slow, store, disconnect and filter the runoff to alleviate the risk downstream. It's not to say that it's going to remove a risk, but it might make the 1 hour storm a 3 hour storm and slightly less violent. The topography, this is a topography catchment feeding down to this former Fosse Lake area. And Bold Street is this street we're looking at in particular. This is Bold Street as it normally is, with a church in the background. And we're going to plant 40 trees on that street. And we're also going to connect tree pits up. So with that runoff going into the soil of the tree intercepting the rainfall as it comes down and actually pumping it back up into the atmosphere. In a perfect world, we could put attenuation in there, but there's just simply not the space. We can't dig up stuff that already exists in the urban landscape. This is a photo from a site in Bolton where a series of 18 properties have flooded 3 times to significant depths. When we walked the 4 kilometre square catchment, most of it was in pipes, including this location, which is a golf course. So these old rivers do exist, and we can recover them in certain locations and give that landscape its natural capacity back. But we need to design and build that, and architects can be part of that in the NFM and master planning stages. So one key fundamental change which may be coming down the road is the National Planning Policy Framework. There's a consultation out at the moment, and rather than where possible, which exists at the present time, it's going to potentially move to net gain. So how do you go beyond greenfield runoff rate retention in your development scenario? And that begs a question of saying, actually, if you're demanded to get a lot of units on a plot, and the plot isn't always the best location for holding up that water, then why not go into the rural areas to do natural flood management, attenuation, and also the cost of that attenuation may be much cheaper. So some of the measures I've just showed you there, around £9 per cubic metre, whereas if you're going to hide your water underground in a detention tank, you might be looking at £50, so potentially quite expensive. And there's also potential yield for the developer too, because a great deal of evidence shows that if your development site is surrounded by good blue-green infrastructure, you can get higher property market values, around 20% in one study. So it makes economic sense as well as environmental sense more often than not. So that's just a quick whistle-stop tour from me, and I'll